Welcome to my channel. If you like my videos, then kindly subscribe, like and watch. Thank you.
Welcome back. Problem 1-50. So the statement is that the driver of sport car apply his rear brakes and cause the tire to slip. If normal force on each rear tire is 40 pound and the coefficient of kinetic friction between tire and pavement is 0.5. Determine the average shear stress developed by the friction force on the tire. Assume the rubber of tire is flexible and each tire is filled with air pressure of 32 psi. So you can see this is a sports car and the driver, when driver applies brakes, so this rear tires produce the frictional force in this direction here. So this is a friction force, and it is also given the coefficient of friction is 0.5 between tire and road, and it is again given that the air pressure in the tire is 32 psi. Also the normal force that is acting on the tire is 400 pounds. So you have to find the shear force between the road. Determine the average shear developed by the friction force on the tire. So you can see that average shear force is equal to shear stress divided by the shearing area. So first of all, we will find the friction force. We do not have the friction force and we do not have the shearing area. So first we will find the friction force and then we will find the shearing area. So for friction force, we know that friction force is equal to coefficient of kinetic friction, which is mu k, into normal force. Clear? Normal force is again given, that is 400 pound, and mu is also given 0.5. So we will put the value which is 0.5 multiplied by 400. That will give you the friction force F. This is the friction force F. When you solve it, so you will get friction force is equal to 200 pound. Now we have find out the friction force, we will then find the area. So as it is given that the air pressure in the tire is 32 megapascal, and we know that pressure is also is equal to normal force per unit area. So normal force is again 400. Clear? That is again given, and we do not know the area. The pressure is given as well, so we will use this equation that A is equal to 400 divided by P, and P is equal to normal force is equal to 400 and P is equal to 32 psi, pound per square inch. So when you solve it, you will get the value of A, which is equal to 12.5 inch square. Now we have shearing area, we have frictional force, so you can easily find the average shear stress. So average shear stress is equal to shearing force divided by shearing area. So shearing force is 200 pound. Clear? And shearing area is 12.5 square inch. So when you solve it, so you will get the average shear stress, that is 16 psi, and this average shearing stress is developed by the friction force on the tire. I hope you have enjoyed this video, as it is a very simple problem. Thank you for watching. Hello. Problem 1-54. So in this problem, it is given that when hand is holding the 5-pound stone, the humerus H is assumed to be smooth. So this is humerus H, that is assumed to be smooth. Exert force FC and FA on radius C and ulna A. So at point C, it is acting a force FC, and at ulna A, it acts as a force FA respectively. If the smallest cross section of the ligament at B is 0.30 square inch, so this is the ligament, so its cross sectional area smallest is 0.3. Determine the greatest average tensile stress to which it is subjected. So you have to find the tensile stress in this ligament. So let's move and solve this problem. So again, for that we have to draw the free body diagram. So I will write down the forces that will be, so due to this stone, so there will be a force that will be acting downward. Clear? And this force will be at point, from point G. This force is 5 pound force. Again, there is at this point there is a force FC, and at this ulna the force is FA, and at this point in ligament, in ligaments there is a force FB. So you have to find the tensile stress. So what you do is that you will have to apply the equilibrium condition. I will apply equilibrium condition, sum of all force, sum of all moment. Let this point is point O. Clear? Sum of all moment about point O is equal to 0, and taking the counterclockwise as moment as positive. So you can see at point O, this is point O, the only force producing moment is 5 pound force, and the second force that is producing moment about point O is the vertical component of this FB. FB have two components, one is Y component and other is X component. So this is FBY and this is FBX. So the only component producing moment about point O is FBY, and this FBY is 75 degree. So the vertical component will be equal to FB into sine of 75 degree. Clear? So we will apply equilibrium condition. The first moment is 5 pound into perpendicular distance from point O is 40 Newton. So 5 into 14. Clear? And it is producing clockwise movement, so it will be negative. The second movement that is produced by this vertical component FBY, and this FBY is equal to FB into sine of 75 degree. And perpendicular distance, you can see here the perpendicular distance is 2 inch, and it is producing counterclockwise movement about point O, so that's why it is positive. So their sum must be equal to 0. When you solve this, you will get this FB force that is equal to 36.23 pound. Now you have this force. Clear? This force. So you can find the average tensile stress to be subjected. So, and that can be found by using stress is equal to force per unit area. So FB per unit area. Clear? So force is 36.23 pound, and the area of this ligament B is 0.30. So when you solve this, you will get the stress minimum tensile stress is 121 psi. So this tensile stress is 121 psi. I hope you have now clear understanding about this problem. Thank you.